Hello everyone, welcome again to my YouTube channel Maths Plus. So today I am going to discuss class 9 NCERT is said to be as polynomial chapter. So what is polynomial if I want to introduce? Before that I want to say something about an algebraic expression. So algebraic expression in the sense if I say 2x plus 5, can you see this? 2x plus 5. So we can say this is an algebraic expression. Why? Because it is containing a constant, it is containing, then here it is a variable, here again a constant is multiplied with a variable, you can see. So you can see here 2 into x, 2x plus 5. So there are how many terms you can see here? 2 terms are there. Still then, if single term is also there, like if I write 3x, this is also an algebraic expression. So we can write as many terms in a polynomial, or we can write single term in a polynomial also. So polynomial in class 9 says the definition as a polynomial is an algebraic expression constituting of constants and variables. So you can see here constants are there, variables are there, even constants are also multiplied with variables to form a product. So we can see in this way the polynomial is an algebraic expression, you can see this, constituting of constants and variables. And even we can find out, see, single term is there, two terms are also there, even we can find more than 2 terms also, 3, 4, 5, 6 like that. That's why we can see terms of the algebraic expression or the in polynomials are separated by what? Plus sign or minus sign, separated. That means you can see here 2 into x, 2x plus 5, or if I write 3x minus 7, so I can see here 3 into x, 3x minus 7. So there are 2 terms and separated by what? Minus sign. Here 2 terms are separated by a plus sign, but here it is a single term, so it is written as a what? Product of a constant and a variable. So we can see in so many ways we can write the polynomial. Single term, then 2 terms, then again if I write like 3x square minus 7x plus 5, you can see there are now 3 terms. On the basis of number of terms, a polynomial can be named as follows. Suppose if I write 3x, so it is said to be a monomial, which has been taught in class 7 also. Even 2 terms if I say, so that is known as what? A binomial. Okay, but if I write 3 terms in an expression, you can see here it is what? A trinomial. So in this way, if you go for 4 terms, 5 terms, 6 terms, we can also say like 4 terms, then that will be known as quadranomial. Then if it is containing 5 terms, then it will be known as a pentanomial. So in this way, we can go for some single term for the type of expressions we'll be having. Still then, again I am saying the definition here. A polynomial is an algebraic expression constituting of constants and variables and terms separated by plus or minus sign. Even we can find the different operations of mathematics also. That means what are they? There are 4 types. Addition is there, minus sign is there, subtraction is there, into is there, multiplication is there. Even division sign can also be used. So we will be going for different types of expressions here, and we can know how the polynomials are written using these operations of mathematics. Okay, but before that I will be discussing the general form of a polynomial. So in earlier classes we have seen that normally we get to know these things we can write in a very simple way, but thing is that we must know the general form of a polynomial when you go to higher class, like from 9th class onwards. So here you can see I have written here p of x. So it is read as what? P of x. It is one type of function. So it will be well acquainted in the higher classes. So p of x means what? A polynomial in variable x. But if I would have written p of y, that means I can say it is a polynomial in variable y. And if I say p of z, I can f of z, so I can say what? It is a polynomial of in variable z. Okay, so in this way whatever within the bracket you will be writing this variable, accordingly we will be expressing them. If I would have written p of y, then you will be seeing this x, wherever I have written x, that would have been converted to y. Okay, so let us see how the general form of a polynomial is written. P of x is equal to what? A n x to the power n. So you see, you can see the formation here. Always it is written like this: a n, then x to the power n. So x is raised to the power n. A n matlab like a can be 1, a can be n can be 1, 2, 3, 4, anything, but not 0. At the end you can see a is 0, but from the beginning you cannot see that n will be 0 here, because I have written in the standard form of the expression. Okay, I have expressed. So I will be discussing that in the next discussion. Okay, so I have written what? A n x to the power n plus a n minus 1 x to the power n minus 1, a n minus 2 x to the power n minus 2 plus dot dot dot, because I don't know how many terms will be there. So I have represented, just you can see the second last term, a1 x to the power 1, and here a0 x to the power 0. Then in the next step I have just finalized the what? The polynomial general form. P of x is equal to what? A n x n, then a n minus 1 x n minus 1, then a n minus 2 x to the power n minus 2. Then accordingly you can see a1 x to the power 1. So 1 is not written, we can ignore it, and plus a0 x to the power 0, and you must be knowing x to the power 0 is equal to 1. It is always equal to 1. That's why x to the power 0 is ignored. We have substituted it with what? Number 1. That's why. Okay. So now go to the next topic. What do we mean by standard form of a polynomial? The standard form means writing the algebraic expressions or writing the polynomial in such a way that the powers of the variables are what here? You can see x. Everywhere where you find x, that is a variable. And if you see an minus 1, these are what? Coefficients of x. Okay. So now you can see x to the power n here, then x to the power n minus 1 here, then x to the power n minus 2 here. So you can see the powers are going and decreasing. That's why I can say this general form is also written in the what? Standard form. And I can say x to the power 0 means the last. Okay. So I cannot go for minus 1 also, because polynomials always represented with positive powers. It cannot be written also in the fractional form also. Suppose if I write 2x, so you can see here, just I discussed 2x to the power minus 1 by 2 plus 5x is not a polynomial. Why? No, because you see the power of the variable is taken to be what? A rational number. The rational number means what? You cannot accept the power as a rational number. You have to always think of positive integers only, like 1, 2, 3, 4, 5, like this. This would be the power of the variables. We can say that will be 1 by 2 or minus 3 by 2. These powers will never be written as the power of the variable. Here also you see 2x to the power minus 2 plus 6 is also not a polynomial. Why? Because you can see here x to the power minus 2 again a negative integer, so it is not accepted. So like that, if I write here p of x is equal to 2x square minus 5x plus 7. So how many terms you are seeing here? 3 terms. And you see p of x means this polynomial is only containing x as the variable. And you see here 3 terms are there: 2x square minus 5x plus 7. So can you find this as in the standard form? Yes, because the power of the variables you can see x to the power 2, x to the power 1, and here x to the power 0. So all are written in the decreasing order of the power of the variables, all the terms. That's why this polynomial is in the standard form. Okay, like as we have discussed in the general form of the polynomial. Okay. Okay, so now you see in this general form, what are the terms, or which are said to the terms of the general form? Then the terms of p of x are here: a n x n comma a n minus 1 x to the power n minus 1 comma dot 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 a1 x and a0. So these are what the terms of p of x. Okay. So now coefficients of each term. So you see the variables are also there, x to the power n, x to the power n minus 1, like that. Now I can say here a n is a coefficient, a n minus 1 is a coefficient, then dot 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 a1 is a coefficient and a0 is also a coefficient. Okay. Now you see a0 is what? A constant term. Constant term has a variable, but thing is that the variable is x to the power 0, which is equal to 1. Okay. So you can see the coefficient also. So you can identify the coefficients of each variable in each term. Now I have written two examples here. You can see p of x is equal to 2x square plus 3x minus 6, which means what? There are three terms and they are in variable x. So now coefficient of x square is what? 2. Here the coefficient of x is 3. Then constant term is minus 6. Here coefficient of y square is what? 3. Here coefficient of y is minus 5. Here it is a constant term minus 7. So you can see easily how the terms are identified and how the coefficients are also identified, that x square is containing 2 as the coefficient, x is containing 3 as plus 3 as the coefficient. So sign has to be also taken to be in the consideration, because in the second case 3y square minus 5y, that means you see coefficient of y is minus 5 not plus 5. So sign has also to be considered, because that's the vital part of the term also. So hope this class is understood by all. So till now what we got to know? We got to know the definition of a polynomial. We got to know the general form of a polynomial. We got to know the terms of a given polynomial, how to identify the terms, and even we got to know how to know the coefficients of each term, which is having like the variable x in these cases. So for that I have mentioned some examples here in terms of x also, in terms of y also. So in this class we got to know definition of polynomial, general form, terms of a polynomial, and coefficients. So let us now jump over to the next topic. So as I told, the next topic will be based upon value of a polynomial. Before that I will be discussing a soft topic like degree of a polynomial. So basing upon the degree also we will be knowing different types of polynomial. Like I will say linear polynomial, which is having degree as 1, and its general form is like p of x is equal to ax plus b, where a is not equal to 0. For example, I can write p of x is equal to what? 2x minus 5. P of y, if I write in another variable, so it will be like 3y plus 1 by 2. I can also write. So you can see here the degree is 1. How? The power of the variable is what? 1 here. So basically the power of the variable only will be identifying the degree of the polynomial is 1 or anything else. The next is what? Quadratic polynomial. So quadratic polynomial degree is what? The degree is 2 here. Degree is 2. And its general form will be like p of x is equal to ax square plus bx plus c. Here also a should not be equal to 0. And I hope you can understand why a should not be equal to 0. Because if a will be 0 here, 0 into x will be what? 0, and plus b will be only a constant polynomial. So now here also if a will be 0, so 0 into x square will be what? 0, and will be remaining with what? Bx plus c. That means it is a linear polynomial. But we require what? Powers should be 2 for a quadratic polynomial. Powers of the variables should be 1 for a linear polynomial. Here also examples I will put. P of x is equal to 3x square minus 5 I can write. P of x, another polynomial I will be writing here, like 4x square plus 5x minus 1 by 2 also I can write. So you can see here the highest power of the variable is what? 2. That's why these both polynomials are quadratic polynomials. So next, let us go to the polynomial which will be having degree 3. So what it is known as? So from the name itself, degree 3 means power of the variable will be 3. That's why the name is stated as cubic polynomial. So let us write the third one is cubic polynomial. Here the degree is what? Degree as 3. So here the general form will be what? Like p of x is equal to ax cube plus bx square plus cx plus d. The condition is again here a is also not equal to 0 here. Same reason. So one the example, let us write p of x, let us write 3x cube minus 5x square plus 7. Another one, let us write f of x is equal to 4x cube minus 1 by 2 x square plus 5 by 7 x minus 2. So you can see here f of x and p of x, two polynomials are written and both are in variable x. So you can see here x to the power 3 here, x to the power 2 here, x here. So I have written every example in the standard form. So you can see the standard form of the polynomials has been maintained here. Okay, so let us go to the next polynomial which is having degree 4. That is known as the bi-quadratic polynomial. So it is having what? Degree as 4. So what is its general form? The p of x is equal to what? Like a x to the power 4 plus b x cube plus c x square plus dx plus e. And here is the same condition, a must not be equal to 0. So it's the same reason, if a will be 0, then this power 4 of this variable will be also vanishing. An example you can mention, one of the example, like p of x, if I take, is equal to 4 x to the power 4 minus 5x square plus 5 is a bi-quadratic polynomial. And another one, let us write f of x is equal to 2x to the power 4 minus 5 x cube minus 2 x square plus 5x minus 7. You can see this is also a bi-quadratic polynomial because you see everywhere you see in these two examples highest power of the variable is what? 4. That's why it is a fourth degree polynomial, or we can say a bi-quadratic polynomial. Okay, so let us go to another polynomial which is having a degree. Can you guess? Degree as 0. So what can be the name of that polynomial? The name of the polynomial is a constant polynomial. So bit E, I'll be writing here constant polynomial, which is having what? Degree as 0. So every constant term, we can say any constant term we can say minus 5, 6, 1 by 2, 0, minus 1 by 7, root 2. These are what? Constant polynomials because they are having degree 0. Can you find any variables attached to these constant terms? No. Why? No, because minus 5 can also be written as minus 5 x to the power 0, which is equal to simply minus 5, isn't it? Because x to the power 0 is what? 1. That's why if minus 5 into 1 will be what? Minus 5. And here you see x to the power 0 means the degree is 0. That's why you see The constant polynomial is a polynomial which is having 0 as the degree. That's why it is also known as constant polynomial. So let us go for the another polynomial, that is your zero polynomial. The next polynomial is what? Zero polynomial. The zero polynomial is a polynomial you will be finding in which all the variables, whatever you have, like the variables x ho, ya y ho, ya z ho, so those variables will be containing their coefficients as only 0. Like one example I'll give: 0x cube plus 0x square plus 0x plus 0. Can you see this? So this is a zero polynomial. Why? Because you see this x cube is containing the coefficient as 0, x square is also containing the 0 as the coefficient, x is also containing 0 as the coefficient, and a constant polynomial, whatever you are seeing here, 0 is also here. That's why this is what? A zero polynomial. Okay, and that's why here the degree is undefined, because you see 0 if multiplied with x power 3, it will be 0 na? So how can you identify the degree of the polynomial? Here the degree is what? Undefined. Degree is undefined. That means we cannot know the degree of this polynomial. Okay, so let us know the main topic I have discussed, value of a polynomial. How to find out the value of a polynomial, as we got to know the types of polynomial till 4th degree. So we can now get into the topic value of a polynomial. Okay, so let us do one example. This topic has been discussed in class 7 also, NCERT book, finding the value of the algebraic expressions. So now here we will be finding what? The value of a polynomial. So let us put an example here. One of the example I am putting here, p of x is equal to x square minus 3x plus 5. So it is a polynomial in variable x. Yes or no? So like I will say, find the value of p of x at x is equal to minus 2. I have taken one negative integer here, x is equal to minus 2. Let us see what can be done. So how to find out the value? That means what we will do, we will be substituting in place of x, I will be putting minus 2 and see what will be the value of this polynomial. So the solution part will be how? So here, given p of x is equal to what? 2x square minus 3x plus 5, and x is equal to how much it is given? Minus 2. That's why, therefore, p of minus 2, if I write like this, then that represents what? I will be finding the value of this polynomial at x is equal to minus 2. So let us find out. So 2 whole into minus 2 ka whole square, then minus 3 whole into minus 2, then plus 5. And you know the operations of integers, and even the exponential form, it is given here how to square it also. So everything will be mixed now. So one type of simplification we can say. So 2 into minus 2 ka square means it will be 4. Then here it is minus into minus plus, so it will be plus 6. So now it is plus 5. So 2 into 4 how much here? 8. 8 plus 6 plus 5. How much it will be? 8 plus 6, 14. 14 plus 5, 19. So what is its value now? So in the concluding part, what you will write? Therefore, p of x at x is equal to minus 2 is 19. Got to know how to find out the value of the polynomial? That means what we did here, we took any real number, because you see minus 2 is a real number. That doesn't mean that only negative integers will be taken or only positive integers will be taken. We can take any real number. That means both a rational number we can take, or we can take irrational numbers. Isn't it? Irrational numbers. Because it's a real number. So it doesn't mean that x is equal to minus 2. I can take x is equal to root over 2 also. So in this way, we'll be finding the value of the polynomial. Got to know? Okay. So any degree polynomial will be given. No need to worry. We'll be substituting x is equal to the value given, then we'll be finding the value, but you should know the BODMAS rule also, because in simplification BODMAS rule is very much important. If you follow this, then this simplification will be easy. If you do not follow this, this will go wrong. That's why simplification rules must be followed while finding the value of a polynomial also, because this rule will be there till you study mathematics. Every time you'll see BODMAS rule will be very much helpful to simplify and get the correct answer. Okay, so let us do another example. I'll be taking one of the rational number. Like suppose if I will take p of x is equal to 3x square minus 2x plus 1 by 2, and will be given find the value of p of x at x is equal to 1 by 2. Here I will be substituting what? X is equal to 1 by 2, one of the rational number. The solution part same way I will be doing here. Given polynomial I will be writing. Even I am discussing how to write the answers. I am not going for shortcut. It is also the way to write the answer. The given is what? P of x is equal to what? 3x square minus 2x plus 1 by 2. And you can see it is written in the standard form. Every time you observe. And it's your duty to write in the answer part the standard form of the polynomial. That will be easy for finding the answer. Now x is given how much? 1 by 2. Therefore p of 1 by 2 will be how much? Let us see. So 3 into 1 by 2 ka whole square minus 2 into 1 by 2 plus 1 by 2. So now 1 by 2 whole square means what? It is 1 by 2 into 1 by 2. That means you see numerator 1 into 1, 1, 2 into 2, 4. So it will be 3 into 1 by 4 minus. Now 2 into 1 by 2, these 2 and 2 will be cancelled. The answer will be what? Only minus 1. Then plus 1 by 2. So now here what happens? It will be 3 by 4, then minus 1, then plus 1 by 2. So as per the BODMAS rule, what we will do? We will first add it. Addition will be done, then we will be subtracted. So I am just putting a line here. So now addition of rational number means what? If they have different denominators, we have to find out the LCM. So is equal to what? The LCM will be 4 here. So 3 will be remain unchanged. And here it is 2. So 2 into 2, 4. So like that. 1 into 2 also. 2 I have to multiply. Then here it is minus 1. So now 3 plus 2 by 4 minus 1. So it is 5 by 4 minus 1. Now again you see 1 is there. It is having a denominator 1. Again I will take the LCM. LCM will be how much? Again it will be 4. Then 5 will remain unchanged. So 1 will be changed to what? 4, because 1 into 4 will be what? 4. So now the answer is 1 by 4. So finally your answer is how much? 1 by 4. So in this way we'll be doing the simplification, use the BODMAS rule, and we'll be approaching for the value of a polynomial at x is equal to any real number. So till now we got to know different things about a polynomial, its definition, general form, standard form, then coefficients, then terms of the polynomials. Then we also got to know value of polynomial, and I have also discussed the degree of a polynomial, and under that heading different types of polynomials basing upon the degrees, like linear polynomial, quadratic polynomial, cubic polynomial, then your bi-quadratic polynomial, then your constant polynomial, then zero polynomial also. So this is a review of this class. So hope till now this much has been understood by you all, and hope I will be discussing the next topics or subtopics of this chapter in the next video. So till then, have a nice day, and please do not forget to like, share and subscribe.